Now see here, in this question different energy levels of the atom are shown here. This is the like first energy level here, this is second, third and fourth. Energies are given over here minus 10 electron volt, minus 4.5 electron volt, minus 2 electron volt and 0 electron volt. Now different transition has been shown here, like this is A, B, C and D. In these four transitions, which transition will give the photon of the wavelength 275 nanometer? This is the first part of the question. So, which transition will give or emit the wavelength of this 275 nanometer? It means which photon will be coming out and having the wavelength this much. So, we can solve it simply. You know it, E is equal to h nu, that is the energy emitted or the energy of the photons coming out during the transition. So, we can write E is equal to h nu, that can be written here h into C by lambda, that is in the joules. So, we can write 6.63 into 10 raised to power minus 34 into 3 into 10 raised to power 8 divided by lambda. We have been given already 275, we have to check it. So, we can write 275 into 10 raised to power minus 9 meter, that I have changed into the meter, into the whole energy will be coming into joules, but everything is given here in electron volt. So, we have to convert this thing into the electron volt. So, we can multiply here, divide by this 1.6 into 10 raised to power minus 19 electron volt. When we put all these values, we get this energy comes out to be around 4.5 electron volt. So, for the wavelength 275 nanometer, energy of the photon required is 4.5 electron volt. Now, look at the different energy levels here. If the the electron or the atom is jumping from this to this, energy difference is 2 electron volt. When it is jumping from here to here, that is also 2.5. When it is jumping from here, that is 8. So, there is for the 4 what one is possible here, 0 to this, it means B transition. So, in this question transition B is possible for the wavelength of 275 nanometer. And also here, if you have got this, also we can get in which case the minimum wavelength will be obtained. So, sorry, maximum wavelength will be obtained. So, maximum wavelength will be obtained if the energy is minimum. So, that is possible only if you are taking from 0 to 2, that is A transition. During the transition A, so the energy is minimum, so the wavelength emitted will be maximum.